Today we're going to explore some more properties of logarithms. You may recall that our calculators can only evaluate logarithms of base 10 or base e, or in other words, the common logarithm or the natural logarithm. So it's important for us to come up with a way that can evaluate something of base, anything else. So let's say that we've got here log base a of x. So a could be anything, could be 3, could be 17, could be 25, as long as it's not 10 or e. Well, that means that we can't put it into our calculator as it is. But what we can do is we can split this up, make this a fraction here, and for the top part, say this log base a of x is the same as log base b, and we get to choose what b is, of x over log base b of a. And since we're choosing what our new base is going to be, oftentimes, because our calculator can use base 10 and base e, we're just going to select one of those. So log base a of x could be log base 10 of x over log base 10 of a. Or we could choose the natural logs and say log base a of x is equal to the natural log of x over the natural log of a. So let's do a few examples. Normally, we wouldn't be able to evaluate these, log base 4 of 25, log base 3 of 17, and log base 6 of 13. But now that we know that we can use a change of base, this here is the same as saying this is the same as log base 10 of 25 over log base 10 of our old base, which was 4. This one is the same as saying log base 10 of 17 over log base 10 of our old base is 3. Or if we want, we could use natural logs. So for this last one, let's use natural logs. This is the same as the natural log of 13 over the natural log of our old base, which is 6. So let's bring a calculator over and find out what these are. Okay, log base 10 of 25. So I'll go to my functions here and I'll put in log of 25 over log of my old base is 4. I see here that's roughly 2.32. Okay, well, let's do that for the second one. Change 25 here to 17 and change this 4 to a 3. So log base 17 or log base 10 of 17 over log base 10 of 3 is roughly 2.58. We'll round that up. And the natural log, so this one we'll do natural log of 13, and we'll say that is over the natural log of 6. Okay, that is 1.43 roughly. So in other words, log base 4 of 25, I couldn't evaluate before. But once I do a change of base here, this I can actually put into my calculator and find out that log base 4 of 25 is 2.32. Same thing with log base 3 of 17. I can now put this in my calculator using my change of base formula, find that that's 2.58, and log base 6 of 13 ends up being 1.43. So we had 2.32 here, 2.58, and 1.43. All right, some other properties. I've got a product property that says if I'm taking the logarithm base a of u times v, so two things that can multiply together, well, I can break that up into two separate logarithms. Say that's logarithm base a still of u plus the logarithm of base a of v. Okay, same thing with natural logs. If I've got the natural log of uv, I can break that up to say this is the natural log of u plus the natural log of v. And if I can do that with multiplication, I can certainly do that with division. So let's say the quotient property says I've got log base a of u over v, u divided by v. Well, with multiplication, this was addition here that separated these logarithms. So with division, it's going to be subtraction. Log base a of u minus log base a of v. Same thing with natural logs. I could do the natural log of u over v is the same as the natural log of u minus the natural log of v. Lastly, the power property. Let's say I've got log base a of u to the power of n. So if I'm taking the logarithm of something with an exponent, I can take this exponent, bring it out to the front, and use it as a coefficient. Log base a of u to the n is the same as n, so taking that exponent, bringing it out to the front, n times the logarithm of base a of u. And I can do that with natural logs too. The natural log of u to the n, take this exponent, bring it out to the front. This is the same as n times the natural log of u. So what we're going to do is we're going to use these properties and we're going to expand some logarithms. Say I've got the logarithm of the natural log of 6 here, and I want to write each logarithm in terms of natural logs of 2 and natural logs of 3. Well, I know that 6 is the same as 2 times 3. So this here is the natural log of 2 times 3. Well, based on the properties that we just talked about, I can split this up into 2 separate logarithms and say this is the same as the natural log of 2 plus the natural log of 3. Okay, what about down here? The natural log of 2 over 27. So this is the same as the natural log of 2. And since I'm dividing, I'm going to subtract the natural log of 27. And I could actually go further than this because I want everything in terms of logs of 2 and logs of 3. Natural logs of 2, natural log of 3. What is 27? 27 is actually 3 to the third power. So this is the natural log of 2 minus the natural log of 3 to the third power. And whenever I'm taking a logarithm of something to some power, some exponent, I can take this exponent and bring it out to the front, use it as a coefficient for that logarithm. In other words, this is the same as the natural log of 2 minus, bring 3 out to the front, the natural log of 3. Natural log of 2 minus 3 times the natural log of 3. Okay, and I can expand these ones too. Log base 4 of 5 times x to the third times y. Okay, I've got these 3 things multiplied together inside of what I'm taking the logarithm of. So I can break this up and I can say all of these are going to be base 4. So log base 4 of 5 plus, because I'm multiplying, log base 4 of x to the third power plus log base 4 of y. And then since this one is x to the third power, I can take this 3, bring it out to the front, and use it as a coefficient. So this is also the same as log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. All right, example G, I've got the natural log of the square root of 3x minus 5 over 7. Okay, well, let's first identify that this is some division that's happening. So I can break that up into 2 separate natural logarithms, one, the top, minus the second, the bottom. So this is going to be the natural log of the square root of 3x minus 5 minus the natural log of 7. Okay, well, 3x minus 5 is really the same as saying 3x minus 5 inside the square root, I should say, is really the same as saying 3x minus 5 to the power of 1/2. So this is the same as the natural log of 3x minus 5 to the power of 1/2 minus the natural log of 7. And since this is an exponent, I can bring that out to the front and use it as a coefficient. This is 1/2 times the natural log of 3x minus 5 minus the natural log of 7. Now this was expansion of logarithms. And if I can expand these, starting with something that's a little more condensed, and then I can bring it out and make it a bunch of logarithms, then I can do the opposite. Here, we're going to condense these logarithms. I've got a whole bunch of logarithms, and I can actually take this expression and condense it into, hopefully, just one logarithm. So what do I've got? I've got 1/2 times the log base 10 of x plus 3 times log base 10 of x plus 1. So each of these coefficients I can bring into what I'm taking the logarithm of and use that as a power. So I'm going to say that this is the same as log base 10 of x to the 1/2. And then I've still got plus, and then take this 3 and bring that over here as well. So this is log base 10 of x plus 1 to the 3rd power. Okay, this here is the same as saying the square root of x, so let's write that. This is log base 10 of the square root of x plus log base 10 of x plus 1 to the 3rd power still. And now let's bring those two together. I'm adding these two logarithms of the same base, so this here can be multiplied to this inside of one single logarithm expression. So this is the same as log base 10 of the square root of x times x plus 1 to the 3rd power, this whole thing. All right, two more. I've got 2 times the natural log of x plus 2, and I'm subtracting the natural log of x. Okay, this coefficient again, I can bring over and make it a power, so I can say this is x plus 2 to the 2nd power. So let's do that first. This is the same as the natural log of x plus 2, and then take this 2 here, bring it over. So this x plus 2 is to the power of 2. Minus the natural log of x. Then, since I'm subtracting these natural logs, I can just make this one expression, one logarithm, with this over this one. So x plus 2 squared over x. This is the natural log of x plus 2 squared over x. All right, lastly, I've got 1/3 times the logarithm base 2 of x plus log base 2 of x minus 4. So first thing I'm going to do is take this 1/3 as a coefficient, and let's make this be a power over here. So this is the same as this is the same as log base 2, and these are going to be added together, so I can actually multiply these. X times x minus 4. Okay, and I've got 1/3 out here still. And so let's clean this up a little bit. This is 1/3 times the log base 2 of x squared minus 4x. Then now take this 1/3 and bring it over and make this my power. This is log base 2 of x squared minus 4x to the power of 1/3. And then lastly, I could say that this power of 1/3 is really going to be the cubed root of what I've got inside here. So this is going to be equal to log base 2 of the cubed root of x squared minus 4x. All right, so hopefully this helps explain some of the different things that we can do with logarithms. You'll have an assignment that's just like this, where you'll be expanding some expressions, you'll be condensing some expressions, and from there we'll just continue learning more about logarithms and how they relate to other functions that we've used before.